A recurring theme in physics is rate or rates. The idea of rates is you want to measure something, a change of something per time. So it's literally change of something per time. Anything per time. And you can figure out, you can understand that why that's really helpful. If you know the rate of something, let's say you want to figure out how long let's say you're filling gas at a petrol pump and you want to exactly figure out how long it takes. Maybe it's a matter of life and death. So if you knew the rate of petrol filling into the tank and the amount of the capacity of the tank, you could quickly figure out, oh, it's going to take you exactly 2 minutes and 40 seconds or something, right? So that gives us a lot of information, and with the rates, you can figure out a lot of unknown things, right? And when in kinematics, rate, you just don't measure rate, you try to measure the rate of rates. And let's see how that works. So the first thing, the most obvious thing you talk about is if anything is moving, how much it moved. So that is measured, or that is called distance. And that's measured in meters, right? And that's literally how much something or someone travels. But the rate of change of distance is really important, and that is understood as speed of something. So a speed at which a car travels can tell you how fast it's going to reach a certain destination. That's going to be measured in meter per second, right? And we go a little ahead. We also try to figure out how fast will something pick up speed, right? So fast over here is not about speed, but like how quickly something will gain speed or slow down. Like if you want to brake, can it brake before it heads into a wall? Like can a car brake before it goes into an accident? Is the brake safe enough? So to figure that out, we have a word for it, which is acceleration, which is, as speed was distance per time, acceleration is speed per time. So I'll take these units and I'll say, oh, that's meter per second. That's meter per second, well, per second. And that turns to meter per second square. It's just dividing meter again. So there are two time units that are dividing meters now, right? So that's what it is. So you have distance, and the rate of change of distance is speed, and the rate of change of speed is acceleration. With our current definitions now, we can work on formalizing it by coming up with formulas. So distance, you got to start somewhere. Distance wouldn't really have a formula, I guess. Distance is just a measurement, and the formula for that, or like the variable for that we use is s. Don't ask me why. All right, so speed, you might know why it's this particular symbol. It's v. And the change of distance is actually velocity. Sometimes you'll say that it's, sometimes you've probably seen it as delta s over delta t. And the delta just means change of. So let's say so this means when you say s, you're trying to think of like, oh, how much did the car travel? So you're like, oh, it traveled like 100 meters in 5 seconds. So the speed is what, 20 meters per second? But over here, when you try to say, you don't know how much it traveled, but you know what its distance was at time when it started and what the distance was after it traveled. So you can figure out how much it traveled by just saying delta S, and that's like start final distance minus initial distance sort of thing, right? Straightforward. Then you have acceleration, and that's again the change of velocity per time, right?